plate about an axis shown. Find the moment of inertia of the plate about an axis shown. Hint, consider an element at a distance of y of thickness dy. Di will be dm into y square. Every part of the element is at the same distance from the axis. Every part of the element is about the same distance from the axis. So dm into y square, you take any part of the element, it will be at a distance of y. So dm into y square, moment of inertia of this element about the axis shown will be dm into y square. Agreed? dm is mass per unit area, length into breadth into b dy. This will be dm. Mass per unit area into b dy into y square integral di. Mass per unit breadth integral y square dy. Least value of y is minus a by 2 plus maximum value of y is plus a by 2. Least value of y is minus a by 2. Y from here till here will be minus a by 2 to a by 2. I is equal to m by a. This will be y cube by 3 m by a. Y cube, a cube by 8 minus a cube by 8. Am I right? This will turn out to be m a square by 12. Moment of inertia of the plate about this axis. I repeat the logic, have a look at it. This breadth is b, this is a. About this axis, it is ma square by 12. Moment of inertia of the plate about this axis is ma square. If this is a, it is ma square by 12. Agreed? What will be the next problem? What will be the next problem? I will ask you the moment of inertia about. You calculated about this, it is ma square by 12. About this, what should you get? Wonderful, you should get mb square by 12. Make it fast. You know the question, you know the answer.
About the z-axis, can we consider a rod at a distance x?
Z-axis I will come to. Wait a minute. After completing y-axis, I will come to z-axis. IZ will be very simple once I know ix and iy.
So can we also do it by considering a rod at a distance x of length dx and use parallel axis theorem and take the sum of...
About which axis are you asking?
Z.
Wait a minute. Now for the same plate, I want the moment of inertia about this. This is given as A, this is given as B. Now I will consider an element dx at a distance of x. Di will be dm into x square, mass per unit area into A dx. This into x square di. Integral di is m by b integral x square dx minus b by 2 to b by 2. This will become mb square by 12. Then the question is, what will be the moment of inertia about the z-axis? As far as the plate is concerned, if I am taking about the z-axis, this will be the x-axis, this will be the y-axis. Right? Iz will be Ix plus Iy. Conditions apply, x and y should be in the plane of the lamina. Right? This will be m, Ix is mb square by 12. Sorry, Ix is ma square by 12 plus mb square by 12. People who want to directly calculate IZ, somebody from ANDHERI was asking, if you consider an elemental strip, distance will keep varying. If you consider an elemental strip this way, in IZ, if you want to consider a strip, distance from the axis here and here will not be the same. So please don't try that. Calculate Ix and Iy, and Iz will be equal to Ix plus Iy.
But sir, by using this method, I got the same answer.
What was the method you used?
At a distance x, I considered a rod of width dx in the z-axis, and I wrote di is equal to m mass per unit area m by ab into dx into b into x square.
How did you get
Plus,
that? How did you get that?
that is, I'm using the parallel axis theorem. First,
कैसा use करोगे यार? This is Iz. You considered an element here. After that, what did you do?
the moment of inertia of that will be dm into L square by 12, which is, and then dm will be equal to mass per unit area into dm.
Okay, listen. What he did is, give me another pen. All of you have a look at it. What he has done, he wants Iz. He used moment of inertia for this thin rod about this axis. Are you clear with that? That he translated about this axis using parallel axis theorem. This is IC. Moment of inertia of the thin rod about this is IC. He used parallel axis theorem and translated about this. That moment of inertia you will integrate from this end to that end. Is the logic clear? Moment of inertia of this thin rod about an axis perpendicular to the rod inwards is ml square by 12. L will be nothing but A here. So it is ma square by 12. Using parallel axis theorem he translated about this. That he integrated from x equal to minus a by 2 to minus b by 2 to plus b by 2. Can I rub the board? Now what if it is a square plate? For a square plate, I am taking both of them out of side A. Now Ix will be ma square by 12, Iy will be ma square by 12, Iz is Ix plus Iy. This will be ma square by 6. Interestingly enough, they just play with the students. They ask what will be the moment of inertia for a square plate about this axis. About this axis. They are actually playing a practical game with you people. This is x-axis, y-axis, z-axis. X and y can be this way, they can be this way. Till when they are in the same plane, till when they are perpendicular, and till when z-axis is going perpendicular to the plane, Iz is equal to Ix plus Iy is applicable, right? So I can write Iz is equal to ma square by 6 is Ix plus Iy. This is x-axis, y-axis. I will get Ix is equal to Iy is ma square by 12. Is it clear? The axis has been rotated, that's it. My all conditions of perpendicular axis theorem will be applicable. X and y should be in the plane of the lamina. They should be mutually perpendicular. Z axis is passing through the intersection of x and y. Iz will remain the same. So you extrapolate that, equate it to Ix plus Iy. You will get the same results as that of the previous case. Now listen. This is an isosceles triangle. I will take this side to be a by root 2 and a by root 2. The moment of inertia about this axis temporarily I am giving you as I0. Find out the moment of inertia about this axis. M is the mass of the plate. M is the mass of the plate. This side is A, this is A by root 2, A by root 2. Moment of inertia about this axis is I naught. Find the moment of inertia of I about an axis passing through the base of the triangle. Think carefully and solve, don't be in a hurry. Moment of inertia about PQ. PQ is parallel to this. PQ is parallel to this. About PQ is I naught. Find the moment of inertia about RS. Find the moment of inertia about RS. If M is the mass of the plate.
Is the center of mass of a isosceles triangle at its centroid or
Centroid. Centroid.
Okay.
Now the question is mainly given for you people to fall for one trap. All the people who take I naught as M into D square will be wrong. D will be this distance. This will be A by 2. Am I right? All the people who took this I naught plus M into A by 2 whole square are wrong. Because this must be the moment of inertia of the body about center of mass. Both the axes should be parallel. That condition is fulfilled. But this is not the axis passing through the center of mass. Then what do you want me to do? Do calculate I about C. This I naught will be I about C plus M into the centroid will divide the median in the ratio 2:1. So this length will be 2/3 of A by 2. 2/3 of A by 2 means A by 3. This length will be 1/3. This is A by 6. Yes or no? 1/3 of A by 2. That will become A by 6. This will be 2/3 of A by 2. This will be A by 3. Agreed? Now I about this axis which you gave me as I naught will be IC plus M into A by 3 whole square. By the way, is this altitude A by 2?
Yes. Yes, sir.
Because this is 45 degrees, right?
Yes.
This altitude is A by 2.
Yes.
Fine. This is A by root 2. This will be A by 2. This will be A by 2. Hence this will be 45 degrees. Now that I know IC, then calculate about this axis. About this axis, I is IC plus M into A by 6 whole square. This IC need to be substituted here to get the value of I. The problem is mainly given for students to fall for the trap of directly applying parallel axis theorem. You are missing on the fact that this must be an axis passing through.
Question again.
Moment of inertia of the triangle about this axis is required. That will be IC plus M into this distance whole square. I don't know IC. How do I get IC? From the information given here, you gave me the moment of inertia about this to be I naught. I naught is equal to IC plus M into this distance square. Parallel axis theorem. I naught is given to you. This is what you know. This IC, if I substitute here, I will get the answer for moment of inertia about this. People who directly apply I is equal to I naught plus M into this distance whole square will be wrong. Because this is not the moment of inertia about an axis passing through center of mass. Parallel axis theorem can be applied only if this is moment of inertia about an axis passing through the center of mass. So first of all, I found out the moment of inertia about an axis passing through the center of mass from the information known. Can I rub the board?
Yes, sir.
By the way, in this problem I gave you the value of I naught. What if I want you to calculate this value of I naught? Please calculate I naught. This value is given as A by root 2. This value is given as A. This is A by root 2. Now consider an element at a distance of y of thickness dy. Every element is at the same distance from this axis. di naught is dm into y square. Now because this angle is 45, this is y, this will be y. Right? dm, mass per unit area. Area is half into base into height into area of this strip. Area of this strip is 2y into dy. This is dm into y square. This will be di naught. You gave me moment of inertia about this to be I naught. I considered a small elemental strip. Distance of every element from the axis will be y. So dm into y square. Right? Technically you will tell me for the small element this will be dic for the small element. dic plus dm into y square. dic will be 0 because this is a thin strip. Thin strip, it's not a solid disk or a plate. Thin strip ka about its axis the moment of inertia will be 0. Mass is only on the axis. So dic will be 0 plus dm into y square. dm I substituted. Integrate this from least value of y is 0, maximum value of y is a by 2. Agreed? Will I get the answer? Make it fast.
Sir,
Huh?
sir, can you please repeat this again?
We found out we considered a small element of thickness dy at a distance of y. Every small element's distance from the axis is y. So dm into y square is my moment of inertia. dm is mass per unit area into area of the strip. Area of the strip is length into breadth. Y square. Integrate from y equal to 0 to a by 2. Agreed?
Yes, sir, got it. Yes, sir.
Think carefully and solve this problem. Don't be in a hurry. This is a solid cylinder. I want the moment of inertia about this axis. L is the length of the cylinder. A is the radius of the cylinder. Solid cylinder. That means you are asking me the moment of inertia about this axis. Solid cylinder. You are asking me the moment of inertia about this axis. Think carefully and solve. Don't be in a hurry. What is the element that you will consider? A disk at a distance of x. So when you consider an element of thickness dx at a distance of x, find the moment of inertia of this particular element about this axis and integrate. Find the moment of inertia of this element about this axis and integrate.
Sir, is it integration of dm r square by 4 plus integration of dm x square? Limits minus L by 2 and L by 2.
Is right. Your final answer will be ma square by 4 plus ml square by 12. इसका आंसर क्या आ रहा है? m a square by 8. Now moment of inertia of this elemental disk about an axis passing through its center of mass DIC is dma square by 4. Do you recollect? For a disk about this axis will be mr square by 4. Listen, the element that you considered is this. The only thing is that this is a ring, but the element that you considered is a disk. You know the moment of inertia about this axis for a disk. It is ma square by 4. Yes or no?
Yes.
All of you? The element that you considered is a disk. You know the moment of inertia about this is ma square by 4. Why are you preferring this? Why are you preferring this? Because using parallel axis theorem I can translate about this. See, this was the disk. So you know the moment of inertia about this axis. Using parallel axis theorem I will translate that about this particular axis. Right? Now di will be dma square by 4. This is dic plus dm into x square. Integrate this from minus L by 2 to L by 2. A is a constant, 4 is a constant. Integrate dm is ma square by 4 plus mass per unit length into dx into x square. Integrate from minus L by 2 to L by 2. You should be getting ma square by 4 plus m L square by 12. We used parallel axis theorem to translate this moment of inertia about this axis.
Excuse me, sir.
Yeah.
Sir, in the previous sum, we took the inertia of the strip to be 0. While here we are taking a small element of the disk and it's not 0. So,
It is
why
not
so?
0, hence you have to take that. If I take a thin rod, about the axis of the thin rod, the moment of inertia is 0 because whole of the mass is at that point. Now for a disk about the axis, this is the disk, about this axis, it is not 0 because there is mass distribution on this side and this side. While for a thin rod, about its axis, the moment of inertia is 0 because there is no mass distribution on either side. Whole of the mass is along the axis.
Okay, thank you, sir.
Sir, sir, how did you take DM as M by L? It's a disk, no?
Huh?
Yes, M by L dx.
To take volume, multiply the numerator and denominator by area of cross section. It gets cancelled out. Disk means I should take mass per unit volume and volume of the disk. For volume, I will have to multiply the denominator and numerator with area of cross section.
Excuse me, sir. Sir, in the previous question, mass is also getting distributed. In the case of the strip, mass is getting
For a
distributed, right?
thin rod or a strip, about this axis, moment of inertia is 0. Whole of the mass is along the axis. A strip will be a thin rod.
But sir, in the previous question, we had taken a triangular plate.
The element क्या लिया है आपने?
Got it, sir. Thank you.
Are you getting ma square by 4 plus ml square by 12?
Yes, sir.
All of you. अंधेरी बैच बैठ के मजे मार रहे हैं यार सामने वाला रूम में मच्छर मार रहा है वो कर क्या रहा है circular disc and another circle is cut out from here. This is of radius r, m is the mass of the dotted region. Another circle of radius r by 2 is cut out from this. Leftover dotted region का mass is m. Leftover dotted region का mass is m. Write down the statement. Find the moment of inertia. Find the moment of inertia of the leftover disk. Find the moment of inertia of the leftover disk. moment of inertia of the leftover disk about an axis passing through O. About an axis passing through O, perpendicular to the board. About an axis passing through O, perpendicular to the board. M is the mass of the dotted region. We want the moment of inertia of the leftover disk about an axis passing through O perpendicularly inwards. About the same axis. Add or subtract moment of inertias when they are about the same axis. अंधेरी नो forget the cockroach यार थोड़ा बहुत physics भी सीख लो यार. Cockroaches can disturb you people to such an extent. The moment of inertia of the complete disk minus moment of inertia of the removed part. Moment of inertia of the complete disk minus the moment of inertia of the removed part. But that should be about the same axis. Moment of inertia of the complete disk I will say is mr square by 2 minus moment of inertia of the removed part will be m r by 2 whole square by 2 will be about O dash. Using parallel axis theorem I will shift it to O. This value, see this is the moment of inertia of the removed disk. Removed disk ka moment of inertia about O dash I know. M naught r by 2 whole square by 2. That using parallel axis theorem I translated about this. Right? This will be the total moment of inertia of the remote disk about an axis O. Now do the subtraction after substituting capital M and M naught. What will you substitute for capital M? Mass per unit area pi r square minus pi r square by 4. Mass per unit area into pi r square. M naught will be mass per unit area pi r square minus pi r square by 4 into pi r by 2 whole square. Substitute this M naught and M here, you should be getting the answer. Simplify and tell me what is the answer that you are getting. You should carefully observe the way we used parallel axis theorem to translate the moment of inertia of the removed part about an axis passing through O dash. That you used parallel axis theorem to translate it about O. I knew the moment of inertia about O dash. I translated it about O before subtracting it. I can subtract both the moment of inertias when they are about the same axis. Observe that carefully.
So,
Yeah?
small m is the mass of the dotted region, right?
Yes.
So, capital M should be small m plus m naught, right? If we assume m naught is the mass of the removed disk.
Right?
So, then what have we done for the capital M thing?
I calculated mass per unit area. Mass per unit area. What is the area? Total minus this will be the area of the dotted region into area of the bigger plate.
So, but then the small m will be the mass of the complete disk, right?
Small m is the mass of the complete disk means then I should have written per unit area only pi r square. What area is this? This area is the dotted region area.
Okay.
Mass per unit area. This area is the dotted region area. That into area of the complete disk. Now if you want to simplify and cross check, I don't mind. M naught plus M. I will get capital M. Substitute those both here, you will get the answer.
Okay, thank you, sir.
Is it 13 capital M R square by 32?
Capital M or small m? Small m.
Capital.
Small m, small m. 13, small m. I should get the answer in terms of this small m given. For this remote disk, m into radius square by 2 is the moment of inertia about O dash. Radius of this is r by 2. mx square by 2 is the moment of inertia of the disk, right? Ij for a disk. X is the radius. And parallel access theorem using this m into d square. What is the formula for the disk? What is the radius of the disk? 2 whole square. This is the radius by 2. M r square by 2. What should be the radius of the disk? R by 2. Mx square by 2. X is r by 2.
Sir, in the bracket, did you apply parallel access theorem?
Exactly. Moment of inertia of the remote disk about its center of mass. IC plus m into d square. This distance is r by 2. Can I proceed?
Sir, what's the final answer?
13
Why?
24.
20.
What if a thin rod is rotating about this axis making an angle of theta? L is the length of the rod, m is the mass of the rod. L is the length of the rod, m is the mass of the rod. Last class notes. Thin rod. Till now for you, you know the formula for this. It is ml square by 3. About the center ml square by 12. But now the rod is not perpendicular to the axis. Rod is making an angle of theta. It will rotate this way. Find the moment of inertia. Make it fast. Consider a small element dx at a distance of x. Dx at a distance of x. What will be the radius of the circular track in which that element is going? That will be x sine theta. Di will be integral dm into x sine theta whole square. Mass per unit length into dx into x sine theta whole square. Mass per unit length sine square theta integral x square dx. Least value of x is 0. Maximum value of x is L. Right? Sine theta, how did you bring it out of the integral? That was a constant.
Yes.
So I can bring it out of the integral. Hollow sphere. Will you try or should I discuss? Moment of inertia of a hollow sphere about an axis passing through the center of the sphere. Kalyan, please listen. Moment of inertia of a hollow sphere about an axis passing through the center of the sphere. Will you try or should I discuss? Please try.
Sir, try.
Make it fast. All of you should try. ANDHERI students who are sitting and chatting will pay a fine of $100 each. What do you want to get? Hollow sphere में ring ही consider करोगे. Hollow sphere के लिए the element that you consider will be this. This will be theta, this will be d theta. This thickness is r d theta. Radius of the ring is r sin theta. You will be considering this elemental ring.
Sir, is the answer 2 by 3 mr square?
सर बाहर गए इनको.
Okay.
सर नहीं सीधा खाना.
2 by 3 mr square.
Thank you.
Right? 2 by 3 mr square. People sitting in that studio room of ANDHERI, please maintain silence. Now di will be dm r sin theta whole square. This was the formula for a ring. Radius of the ring is r sin theta in this case. mr square is the formula for the ring. Right? dm mass per unit area into surface area of the ring. 2 pi r sin theta into r d theta. R square sin square theta will be di. Mass per unit area into area of the ring into r square sin square theta. Right? Integral di m by 2 r square sin cube theta d theta. Least value of theta is 0. Maximum value of theta is pi by 2. When I consider the ring at the topmost point, theta is 0. When I consider the ring at the lowermost point, theta is pi. Right? Do we know the integration of sin cube theta? Please do follow this way. You can write it as sin square theta d theta. Agreed? Sin square theta 1 minus cos square theta. Advantage, let t be cos theta. dt will be minus sin theta d theta. The integral will become 1 minus t square. dt with a negative sign. Do I know the integration of this? Once I know, substitute the value of t as cos theta and then substitute the limits of theta. Theta equal to 0 to pi. Agreed? This will turn out to be minus t cube by 3. That means mr square by 2 minus of t was cos theta minus cos cube theta by 3, 0 to pi. Substitute the limits, you must be getting the answer 2 by 3 mr square. And you should remember the value.
Now what is his answer?
2 by 3 mr square. Are you getting the answer? People who directly write the answer after this step will be made to stand upside down. Please do the simplification and get the answer. Don't copy it from your neighbors. That is called simplification. You can do it on your own. Substitute pi here. You should know the value of cos pi. Cos pi whole cube minus, substitute 0 in the place of theta. Addition and subtraction. I believe you will be able to do. 2 by 3 mr square. You must get the final answer.
Yes, sir, got it.
Using this result, solve for a solid sphere. Solid sphere ka I'll consider a small elemental hollow spherical shell of radius x and thickness dx. Use the result of a hollow sphere, your job becomes much easier. Quick. Shh. Quick. M is the mass of the solid sphere. Disk will be perfectly okay. You'll have to follow the whole procedure. Shortest will be by considering a thin spherical shell.
Okay, sir.
Moment of inertia of a hollow spherical shell is 2 by 3 into dm into x square. 2 by 3 mr square was the moment of inertia. Dm is the mass of the shell. Dm is the mass of the shell. X is the radius. X is the radius. Integral di is 2 by 3 integral dm. Mass per unit area, mass per unit volume, 4 by 3 pi r cube into volume of the shell. Volume of the shell is 4 pi x square dx. Mass per unit volume into volume of the shell. Right, volume of the shell is surface area into thickness. Right, 4 pi will go, 3 will go, 2m by r cube integral x to the power 4 dx. Least value of x is 0. Maximum value of x is r. 2 by 5 mr square is the moment of inertia of a solid sphere about an axis passing through the center.
Sir, can you explain the first step?
2 by 3 mr square was the moment of inertia of a hollow sphere. So hollow spherical shell ka formula will be taken. dm is the mass of the spherical shell. Mass per unit volume into volume of the shell. That you integrated. You used the formula of the hollow spherical shell. Now somebody from ANDHERI was asking for something.
Yes, sir.
Sir, I'm trying to say that we got the moment of inertia of solid sphere less than the moment of inertia of hollow sphere. So does that mean that it's easy to rotate a hollow sphere or a solid sphere instead of a hollow sphere?
Yes, we will do these comparisons also. We'll make all of them roll down in inclined plane and we'll see which one is coming down by a greater acceleration, lesser acceleration, greater velocity, lesser velocity. All comparisons will be done. Don't worry, I assure you I'll put you through the maximum possible trouble. Let me summarize everything that we have learnt as far as moment of inertias are concerned. You will have to remember these formulae. First of all, you dealt with moment of inertia of a rod about an axis passing through the center and about an axis passing through one extreme end. Then you dealt with parallel axis theorem. Parallel axis theorem, I is IC plus M into D square. 2 points you should never forget here. The two axes must be parallel. Second, this must be passing through the center of mass of the body. Then we said perpendicular axis theorem. IZ is Ix plus Iy. 2 points that I should not forget here. Ix and Iy should be in the plane of the lamina. Apply this for a planar lamina only, not for a three-dimensional body. Parallel axis theorem can be applied for a three-dimensional body as well. For a ring, this is mr square about an axis, x-axis or y-axis. It is mr square by 2. For a hollow cylinder, about this axis will be mr square. For a disc, about this axis will be mr square by 2. This is mr square by 4. Solid cylinder, mr square by 2. This is a solid cylinder. Plate, this will be m a square by 12. This will be m b square by 12. So Iz will be ma square by 12 plus mb square by 12. So Iz ma square by 12 plus mb square by 12. Right? For a square plate, this will be x, this will be y. Or I can as well deal with these both as x and y. Ix is equal to Iy is ma square by 12. Iz ma square by 6. Hollow sphere 2 by 3 mr square. Solid sphere 2 by 5 mr square. Hollow and solid spheres, you know the moment of inertia about an axis passing through the center. Right? These formulae written on the board, you must have it on the tip of your tongue. Any other structure asked, please use calculus or parallel and perpendicular axis theorem to get the required answers. Quick, summarize them, make it fast. Next class when I ask you any of the formulae, you falter or you take time to tell me the answer, you will be hanged upside down.
Sir,
Yeah.
sir, वो doubt lecture collisions और center of mass का
गौतम को बुलाओ यार, क्लियरली बोलो इनके लिए अरेंज होगा. गौतम को याद दिला दो नेक्स्ट वीक टाइम टेबल यार कब तो टाइम तो बताने के लिए बोलो.
सर असाइनमेंट कभी डिस्कस करोगे?
Sir, we have not received the assignment.
It has been sent to your respective center. Please talk to your center manager. If not, I'll take a photocopy and post it on the WhatsApp group if you make a group. By the way, exercise one of the booklet doubts I have taken in one of the sections and uploaded that. HCV also I have taken and uploaded. Right? What are left over is exercise 2, 3 and 4. That's all of the booklet. Conservation of momentum and the assignment. Right?